In previous video, we saw how we can calculate probability using this classical definition of probability, and we have been introduced to these three axioms of probability. Let's find probability in specific cases. Here is a standard pack of playing cards holding the deck of 52 cards inside. Cards are well shuffled inside this pack. If we take the cards out of it, we can see these 52 shuffled cards. If we arrange these cards properly, we can notice there are 4 suites of cards actually. Each of these suites has 13 different cards with specific values through ace, 2, 3, this way till jack, queen, king. Now suppose from this well shuffled deck of 52 cards, we draw 2 cards. What is the probability that both of these cards are aces like this? So here is our question in little more formal words. 2 cards are drawn at random from a standard deck of 52 playing cards. What is the probability of getting 2 aces from the deck of cards? Let's try to find the solution to get the answer to this question. These are all well shuffled 52 cards from this pack. We want to draw 2 cards from the deck of cards in this pack. That means we want to pick 2 cards randomly from 52 cards. We can do that in 52C2 ways, as we are just selecting group of 2 cards out of these 52 cards. This is the count of mutually exclusive, equally likely, exhaustive cases in the sample space for this random experiment. Now we need to think about the favorable cases. Let's assume A is the event in which we get the 2 cards as 2 aces only. Which are the aces here among all these cards? If we arrange properly, we can see we have only 4 aces here. Ace from club suite, ace from diamond suite, ace from heart suite, ace from spade suite. In how many ways we can select group of 2 aces from these 4 aces? As example, we can select 2 aces this way, or in this way. We can select 2 out of these 4 aces in 4C2 ways. This is the count of favorable cases belong to the event A. So probability of getting 2 aces when we draw 2 cards from a deck of 52 cards will be the ratio of these respective counts, which will be equal to 1 by 221 if we calculate. This is the answer to this question. Now we have another question here for a different situation. Instead of drawing 2 cards together, if we draw the cards from this pack one by one and replace the cards also. As example, let's draw 1 card randomly. We get 2 from diamonds suite. Just record this value. Replace this first card to the pack. Draw the second card. We get ace from spades suite. Record this value. This way, when we draw the 2 cards, notice that values we get can repeat here. As the card from first draw, we can draw it again in second draw because we replaced it after first draw. As a result, if we get 2 from diamonds in first draw, we can get 2 from diamonds again in second draw. Now if we draw 2 cards this way, what will be the probability that the 2 card values will be aces, just like this or like this? So here the second question is, what is the probability of getting 2 aces from the well shuffled deck of 52 cards if the first card we draw is replaced before the second card is drawn? Let's find the solution here. These are 52 well shuffled cards. We can draw 1 card randomly, record the value and replace it. This same card we can draw again, record the value. That means we are arranging 2 out of 52 card values here when repetition is allowed. We can do that in 52 to the power 2 ways, which is the count of all possible mutually exclusive, equally likely, exhaustive cases belong to the sample space for this random experiment. Let B is the event to draw 2 aces here, and these are 4 aces here. Let's think about the favorable cases for the event B. In a favorable case, first draw can be like this, second draw can be like this. Because of the replacement of the first card, the aces can be from same suit like this. That means repetition is allowed in favorable case as well. So we can arrange 2 out of these 4 aces in 4 to the power 2 ways when repetition is allowed. This is the count of favorable cases belong to the event B. So the probability of getting 2 aces when first drawn card is replaced will be the value in this ratio. 1 by 169 is the answer to the second question. Let's keep these cards back in the pack and move to a next question on finding probability in the next video.